Hi guys. So I'm going to do the title of it, domain and range wrap. Okay. Kind of wrap it up. I did this in Saturday tutorials. I made a little chart, and so I'm going to kind of replicate that as a video. And kind of generalize domain and range as far as transformations and how it changes it, and more specifically asymptotes. Okay, so let's look at cosine and sine. So if we had a function f of x equals a cosine or sine, behaves similarly, plus d, and we can use Sham's d b q is rad. And Sham claims that I came up with the DBQ part, but I wouldn't have even thought of DBQ. He thought of the whole thing. He said DBQ is rad. And we're kind of contesting it right now, but I'm sure, because I mean, DBQ is the farthest thing from my mind. I haven't done a DBQ since high school. So let's take a look. Domain and range. And domain is so easy. It's all real numbers. No matter what A, B, C, or D are, domain is not going to change. It's going to be all real numbers. So you got that right on the test. Okay, now the range, if you look at the cosine and sine range, the outputs, okay, I kind of marked them for you. Right here, here. It's between 1 and -1, okay? It's between 1 and -1. And remember, though, these are called maximums right here. Those are maximums here. And these are minimums, okay? So we call it domain and range. So we know that plus or minus 1 is going to be affected because those are the maximums and the minimums. Okay. Usually, yeah, there's nothing that is greater than that or less than that in the parent function. So if you look at the range, it's affected by A and D in that order. So I'm going to multiply it by A and add D to it for both plus or minus 1. I could kind of, let's go ahead and separate that out so it's clear. So 1, I'm going to multiply it. I'm going to multiply it by A and then add D to it. And that should be the new maximum. Unless it's been flipped upside down. Okay? Unless it's been reflected over the x-axis. And A is negative. Then the max becomes a minimum. -1 times A plus D equals min. So, for example, if I had the function f of x equals, let's make this 1/3 cosine, and B, C does not matter. It's always going to be all real numbers, plus, I don't know, 1.5 or something like that. Okay. Then I would take 1 and multiply it by 1/3 and add 1.5 to it. Why did I pick these numbers? I don't know. So that's 1/3 plus, is that 3/2, 1.5. And so that's 6/2 plus 2 plus 9. So 11/6. So that means that let's go ahead and save that until later. And -1 times 1/3 plus 1.5 equals -1/3 plus 3/2 equals the 6, and now it's 2 minus 9 equals 9. It's -7/6. So that is the new minimum, and this is the new maximum. So for this, the domain is going to, the range is going to be y. It's going to be -7/6 equal to y is 11/6 once you write the rest of the business. Okay? Got it. Next, moving on to the more difficult. Let's do tangent and cotangent. Okay, Harshita's favorite. So f of x equals a tangent b x minus c plus d. And so the domain, now if you look at tangent and cotangent, there is clearly asymptotes. And when we look at the domain range, so domain is all real numbers, and it excludes the asymptote. So for tangent, it is x equals pi halves plus pi k, and then k is an element of all real numbers. For cotangent, it is x equals, and then it's pi k, but it's actually 0 pi k. K is an element of not all real numbers, but integers. If you look at cotangent, the first asymptote is right here on 0. Well, the one that starts that period is at 0. And for tangent, it's at pi halves. So if you look at the period, what exactly that asymptote is saying is that within this one period right here, tangent's period is pi, there exists one asymptote. And so if you break that down, that asymptote right there, and if I put a 0 here, then that is going to be x equals pi halves if I put a 1 there. So this pi that gets multiplied to k for tangent and cotangent, if you look at cotangent's period from here to here, it's actually separated by a period. So we can say that there's only one period, or there's really one period one asymptote in the period, because this one starts and that one starts the new period. That starts the new period. Okay, so that's where the pi comes from. That's the period. And this is the, well, first asymptote, as we say. Not necessarily the first, but we're starting in that first quadrant. We're between 0 and pi halves. Okay. So when you look at how it changed, we know that it's dBc or dBq. B, we're going to take B and multiply it by, not B. We're going to multiply B with that first asymptote, because when that first asymptote changes period, it's going to be affected by the period change, a horizontal stretch or compression, and it's going to be moved right or left, right or left C spaces, just like we did on the tables for the X values. So we're going to multiply it. Remember, we have to take the reciprocal of this and take the opposite of that. So 1 over B, and then we're going to add C to it. Okay, and be mindful that cotangent actually has a 0. And then when we write the asymptote, that pi is going to now change into the new period. So for example, if I had something like f of x equals, let's put 1/3 tangent of, I'm going to save some time and make this like a 1/2 x minus pi over 2 and plus 2/3, something like that. And so that means that it's tangent. So my parent, for my parent function, I shouldn't have put it there because that's where my range goes. Let's see if I remember. X equals, I think I had 1/3 tangent, and then I had 1/2 x minus pi over halves plus 2/3. This is my A value, this is my V value, that's my C value, and that's my D value. Now remember to take the reciprocal of this, and we're going to add pi halves. Okay, so to the asymptote, x equals pi over 2 plus pi k, I'm going to now multiply this by 2 and add pi halves. So that gives me a pi plus pi halves, which is 3 pi halves. So that's my first asymptote. Just check. Pi halves times 2. It's way too early in the morning to be doing asymptotes. Sorry, even for me. And then pi. Okay, and then remember I said that that's the new period. So period is, no, I want to confuse you. B equals 1/2 and C equals pi halves. But in order to multiply it, we have to take the reciprocal. We have to actually, in order to apply it to the x values, we have to take the reciprocal. Okay, and that's why I multiplied it by 2 right here. The period is going to be, the period of this is pi over b. So that's pi times 2. So 2 pi k. K is an element of, so that's your asymptote. It can't equal that. And x such that x is an element of a real number. Now for the range, it's easy. Y is an element of all real numbers. That's not going to change. Okay? Now, the last of the bunch, the cosecant and secant. Domain and range. Okay? So for example, we have f of x equals, let's go ahead and put, I don't know, 3 times, let's do a cosecant. And then let's do a 1/2 times x minus or plus. Let's do a pi over 4 and minus 3, something like that. Remember, that is the A, that's the B, that's the C, and that's the D. 3, 1/2, negative pi over 4, negative 3. That's the B value, but to apply these two, I already took the opposite of that, but we're going to multiply by 2 and subtract pi over 4. Okay, and that goes on the domain. And these two over here, I'm going to put on the range, and that's going to be multiply it by 3 and subtract 3. Okay. Now, the thing about cosecants and secants is that there's no all real numbers on either domain or range. If you look at cosecant and secant, domain has an asymptote, and then the range has this gap, this little space, right here. Okay, and so numbers that are in that gap are not included in the range. Okay, so for the asymptote of cosecant, it should be pi k, and it is pi k, just pi k. But what you have to understand is that there's actually a 0 plus pi k. K is an element of all real numbers. Because if you look at cosecant, that's the start. So it's 0. And then after pi, there's pi and 2 pi. So, and remember that from here to here is the period. But notice more importantly that there is an asymptote smack dab in the middle of that period. So if this entire period is 2 pi, then I divide that by 2 to get from 0 over here, 0, to the next period. And that's what this says. I started 0, and whatever the period is, k is, I take, this is the period, if you look at it, divided by 2. And for secant, the same thing. X cannot be pi halves plus pi k. K is an element of integers. Here too, if you look at secant, here is pi over 2, but from here to here are my periods. Okay, so
Or we can say, not necessarily there and there, but as long as you have two of the same outputs. So I can say from here to here are my periods between the two asymptotes, but there is an asymptote smack dab in the middle. So you have to take your period and divide it by 2. And that's the first period. And you're going to take, so both of these first, so that first number, how do I write this? How did I write it up here? I kind of did it like this. So for that first number, both of them, you're going to multiply it by 1 over b and add d to it. No, c, I'm sorry. Add c. For this, you're going to take the period, whatever the new period is, the transform period, and divide by 2. Okay. I wrote all over the range space, but doesn't matter. This is not turning into a pretty table. So in my example, it was a cosecant. So my asymptote was x equals 0 plus pi k. K is an element of integers. I'm going to take that first period, multiply it by the reciprocal of 1/2, which is 2, and subtract pi over 4. So that this becomes negative pi over 4. And then, what's my new period? My new period is determined by my b value. So my b value is 1/2. So that's 2 pi over 1/2. So that's 4 pi. Okay. Now I'm going to take that new period right here, and I'm going to divide it by 2. Smack dab in that period, there is going to be an asymptote. Tangents, it started with a period, the period started with an asymptote, it ends with an asymptote. There are no asymptotes in between. So that's why it's the entire period. For this, it's half the period, because that's where the asymptote is. So 2 pi plus 2 pi k. K is an element of c. So that becomes part of, and that can't equal that for my domain. Now for my range, let's go ahead and use a different color. I'm going to use pink. For range, remember there was a gap, right? The yellow highlighted gap right here. Where did the gap end? The gap ended at 1 right here and -1. So you can kind of think of it as a cosine and sine, where those were the maximum and minimum values. This time, this is where the start of the range happens, what y values can be. So I can just take plus or minus 1, and I can multiply it by a value and add it to the d value. There's my rad. Okay, so for this example, my value was 3. So I'm going to do plus or minus 1 minus 3, and I'm going to end up with a 3 and a 0, and a -3 and a -6. Okay, so there you go. So that's the range y, such that y is an element of real numbers. Remember, it's not between them. the y values are not between those two numbers. It's less than or equal to the smaller of the values, or greater than. Oh, that is definitely not the smaller of the values. Or greater than or equal to the larger of the two values. Okay? I hope this helped. Yeah. I hope this helped. I mean, Shams D B Q is rad, and remember we have to do opposites, and reciprocal. Okay. I hope this helps. Thanks, Sham.